Hello and welcome to Chemistry Nuggets, where you can polish your knowledge and clear your doubts. Friends, today's video is the part 4 of the Thermodynamics class 11. In this part, we will study about the change in internal energy by work and by heat. So let's start. Change in internal energy by work. Friends, in the part 3, we studied about what is internal energy and what is the change in internal energy. Now, we studied that we can change the internal energy by 3 ways. First one is by work, we can change the internal energy. Second point is by heat, we can change the internal energy. And the third is by the mass, we can change the internal energy. So, in these three, we will study first of all how the internal energy will change by work. So in this portion, we have to suppose we are taking a container which is adiabatic. Now we have a container and it is having some liquid, and this is a adiabatic with adiabatic balls. Now, don't get confused with the adiabatic walls. Adiabatic walls mean it allows transfer of energy by work and not allow transfer of energy by heat. So, such type of system which not allows the transfer of heat, that system is called adiabatic system, and the walls of that system are called adiabatic walls. So now here, why we are taking adiabatic system? Because we want to see how only with the help of work we can change the internal energy. So we will take the adiabatic one so that Q will be 0 here. Now here in this case, Q is equal to 0. There will be no heat transfer. Now what is going on here? We have a system, adiabatic system. Now we have to change the internal energy. What we should do? We can't give the heat because there will be no heat transfer. Then to change the internal energy, the other thing is to do some work. Okay, we'll start doing some work. Put a straw in this container and start churning it. What will happen? The temperature of the liquid inside will rise. It means the state of the system will change, and the state of the system changes means internal energy also change. So in this way we can say the change in internal energy delta U is equal to total work done by the system or on the system. So we can say here W adiabatic. Delta U in this case is equal to the work done by the system or on the system. Now in the same condition, if we are not doing the mechanical work, we can do the electrical work also to change the temperature. So if we put the immersion rod in this container, then what will happen? Again the temperature inside will rise. It means the state of the system change. If the state of the system change, it means change in internal energy also happen. So again we can say that by this two process we can come to the conclusion that work done by the system or on the system in the adiabatic container is always equal to the change in internal temperature. It doesn't depends on the path of the process. Either it will be mechanical work or it will be electrical work, as I proved here. So delta U is a state function. Now if adiabatic work done is equal to the change in internal energy, now we have to see the sign conventions whatever we should use. So if the work done by the system, now in this same work done by the system, then W adiabatic will be taken as negative. Because system is working, it means energy is going out. If energy is going out, it means internal energy will decrease. And if internal energy is decreasing, it means we will take it negative. Now, if the work done on the system, in that case, W adiabatic will be positive. We will take it as a plus sign, because in this case, the work is done on the system, so that the system's energy will be increased, so that internal energy will also increase. So increase means gain is always positive. So in this way, make sure you should understand the sign convention. It is used in the numericals. Now this point is over. Next come to change in internal energy by heat. We studied by work. Now we are coming to the next topic, by heat. Now heat we denote by Q. Now actually what is heat? Exchange of energy between the system and the surrounding due to the temperature difference is called heat. This is the actual definition of heat. Fine. Now second and important point is heat always transfer from higher temperature to the lower temperature. If system temperature is higher than the surrounding temperature, the heat will go out from the system to the surrounding. If surrounding temperature is higher than the system temperature, then heat flows from the system to the surrounding. It means heat always transfer from higher temperature to the lower temperature. Now delta Q, that is heat, is denoted by Q, and we should understand that delta U is equal to Q when we are taking a system with conducting walls. Now assume a system with conducting walls. This is a system having conducting walls. It is thermally. So we have a system having thermally conducting walls. Now what we can do, if we keep this system in a reservoir and the reservoir temperature is T2 and the system temperature is T1. So we can see clearly that there is a temperature difference. Fine. If there is a temperature difference, it means definitely there is a flow of heat. Flow of energy in the form of heat, we can say. Where? From higher temperature to lower temperature. Now, if there is a flow of energy in the form of heat, then what will happen? The system's temperature will differ from the initial state. Definitely the system temperature will be changing. Okay. So if the system temperature is changing, it means its state is changed, system state is changed. And if the system state is changed, it means we can say the internal energy also changed. So in that case, delta U, that is change in internal energy, is equal to the heat transfer, Q. So we can now be clear how the internal energy change with the help of heat. Now, this is the concept behind this. Come up to the sign conventions for heat transfer. When the heat transfer from the system to the surrounding. Now from the system to the surrounding, it means system temperature is more than the surrounding temperature. So heat will go out from the system to the surrounding. If heat is going out, it means internal energy will be now less. Okay. If internal energy is going to lose, then what will happen? Energy loss, it means the sign will be negative. Okay, we can say it is loss of energy. Now next point is when heat transfer from the surrounding to the system. When surrounding is having more temperature and system having less, then the temperature flow direction will be from the surrounding towards the system. It means from outside to inside. If system is taking the heat, it means the temperature will rise inside the system. Temperature is right, it means a gain in energy, gain in internal energy. So gain always have the positive sign. When we have a gain in internal energy, it should be taken as positive sign. So friends, this much is enough for understanding heat and work. Now come up to one more point. Now change in internal energy, if we study it together, change in internal energy by heat and work. So in normal cases, it is not possible only by heat or only by work, but we have to study it together. In whole, when we study, then the equation comes out delta U, change in internal energy, is equal to heat plus work done. This is called the internal energy total. Now this is also mentioning that energy neither be created nor be destroyed. Whatever work we are doing, whatever heat it is taking or giving out, the total, the sum of all that thing is equal to the internal energy. Fine. It means energy neither be created nor be destroyed. It won't be less or more. The total sum will be equal to the internal energy. Now this is also called as the first law of thermodynamics. This delta U is equal to Q plus W is called as first law of thermodynamics, which states that the total energy of the system is equal to the heat and the work done. Now one more point to be mentioned here, which is important, that in an isolated system, what I am telling, isolated system. Isolated system means there is no exchange of work, there is no exchange of heat. So if there is work is equal to 0 and heat is also 0, then in that case change in internal energy will also be 0. So remember, every time when we talk about isolated system, in that case the change in internal energy will always remain 0, because in an isolated system there will be no work and there will be no exchange of heat. So friends, with this we have now going to study some cases. Now case 1. So these are while studying the cases, the main purpose is what are the changes in the first law of thermodynamics we are going to see. So normal first law of thermodynamics says delta U is equal to Q plus W. It means change in internal energy is equal to heat plus work. Okay. What is energy in the form of heat plus energy in the form of work? Together it makes the internal energy of the system. This is called the first law of thermodynamics. Now if the work done by the system and heat is supplied to the system, in that case what will be the first law of thermodynamics? So there will be a slight change. In that case, work done by the system. So W will be by the system, work is done, W will be negative because energy will be going down. So it will be negative, and heat is supplied to system. Q will be positive because heat is supplied, it means gain in energy. So in that case, what will be the delta U? Change in internal energy in this case will be Q minus W. This will be the expression for the case 1. Now in case 2, when work done on the system, in that case W will be positive, because if we are doing work on the system, it will means the internal energy will increase. So positive. And heat is evolved from the system, it means Q will be negative. Heat is evolving means going out. So internal energy will decrease. So negative. In that case, change in internal energy is equal to W minus Q. Or we can say plus W minus Q. That is also correct. Okay. So these are the few changes we are doing in the first law of thermodynamics while we are going through the different processes or different types of conditions. So friends, that's all for today in this video. Hope you guys understand how work and heat relates with each other and how it is able to change the internal energy. So friends, thank you for today's video. Please do like, share and subscribe, and don't forget to press the bell icon so that you will be connected with me for the next coming video. Till then, thank you.